Today we're going to go ahead and solve and graph inequalities using addition, subtraction, multiplication, and division. We're going to do all four operations. We're going to solve and graph the inequalities. Make sure that you title this in your math journal at the top of your page, and you also title your table of contents. When we solve inequalities, it's just like we did with equations. You will remember if we have -4, we will add 4 to both sides. If we have adding 8, we subtract 8 from both sides. So it's just like solving equations, but now we're going to be using our inequality symbols. So let's take our first problem. X minus 4 is greater than 5. Notice I have my inequality symbol here. I do not have an equal sign. Also remember, you can pause at any time you need to so you can keep up with these notes. So x minus 4 is greater than 5. Well, I need to get x alone, just like we did with equations. So in order to do that, I'm going to add 4 to both sides. You must show all of your work. So these 4's cancel out and I'm left with x is greater than 5 plus 4 is 9. So that'd be your answer. So first we just solved the inequality, but now we need to graph the inequality. Your graphs don't have to look exactly perfect. So I usually just pick like my number that I'm working with, which is 9, and I do 2 below it, 2 above it. That's just what I do. All right, so we've learned graphing inequality. So now we're going to take this inequality and we're going to go ahead and graph it just like we did the other day. So I have x is greater than 9. So I'm working with 9, so I'm going to put my circle on 9. Now since I don't have the equal sign, it's going to be an open circle because my answer cannot include 9. And x is greater than 9. And there's my graph. Because remember, if I were to put in here, if I were to replace x with 9, is 9 greater than 9? No, it is not. That's why I have to have the open circle, because it's anything greater than 9. So if I had 10 greater than 9, yes. So there I have anything greater than 9. That's why we have the open circle. 11 greater than 9, yes. 50 greater than 9, yes. So anything that's greater than 9 could be part of the solution set for this. And again, remember, we have our open circles and our closed circles. Our open circle does not include the number, but our closed circles do. Let's try another problem. X minus 6 is greater than or equal to 4. X minus 6 is greater than or equal to 4. Again, I have to get this 6 by itself, and it's minus 6, so the inverse operation would be to add 6. I must do it to both sides and show my work. These 6's cancel out, and I am left with x is greater than 4 plus 6 is 10. So first I solved it, now I need to graph it. Just made my graph again. I'm working with 10, so I pick 8 and 9 below it and 11 and 12 above it. So I have to graph x is greater than or equal to 10. My number that I'm working with is 10, so I'm going to put a circle on 10. And I'm shading it in, unlike I did with the 9, because I have the equal to sign, because x can be 10 or greater, right? So x is greater than 10 or equal to 10. So for example, if I said plugged in 10, is 10 greater than or equal to 10? Yes, it is. So that's why I shaded it in, because it is part of the solution set. Is 11 greater than 10? Yes, it is. It's part of the solution set. What if I had 50? Is 50 greater than 10? greater than or equal to 10. See, these are all greater than or equal to. So 10 is greater than or equal to 10, 11 is greater than or equal to 10, 50 is greater than or equal to 10. So all those numbers can be part of the solution set. Remember, pause the video at any time in order to keep up. What if I had this problem here? What if I said 10 is greater than or equal to x minus 1? With equations, it didn't matter which side the equal sign was, or the variable was on the equal sign, but it does matter when we're reading our inequalities. So first thing we need to do is get x alone, just like we've been doing, right? So I have minus 1, so in order to get rid of this minus 1, I'm going to add 1. Just like we did with the equations, these cancel out. I'm left with x on this side. There's my inequality symbol, and 10 plus 1 is 11. So there's my solution. But we've been reading them left to right. So for example, in this problem, we read x is greater than or equal to 10. X is greater than or equal to 10. Because remember, the smaller number eats the bigger number, so wherever the open side, it's going to be greater. So here, I read this, x is less than or equal to 11, because 11 has to be greater. So I'd say 11 is greater than or equal to x, but now I'm reading it backwards, and I'm saying x is less than or equal to 11. So let's see how we would graph this. Okay, so my number that I'm working with is 11. So I did 2 below it, 2 above it, just on my graph. Again, you don't need more than like 5 numbers, that's fine. Plug in my 11. I know I have the equal sign, so it's going to be shaded in and closed. And I'm reading this backwards, starting with the variable. X is less than or equal to 11. So now I'm going to draw my arrow this way because x is less than or equal to 11. Remember, smaller numbers eat the bigger numbers. So anything, all these numbers have to be 11 and below. For example, plug numbers in to help you out if you can't figure out which way to put it. 11 is greater than or equal to 11? Sure. But I said we had to read backwards, right? X is less than? Okay, so since x is less than, let's try 10. Oops. Is 10 greater than or equal to 11?
Call from.
Oops, I think I wrote that backwards. Sorry, got distracted by the phone. 11 greater than or equal to 10. There we go. I'm plugging in for my value for 10 for my variable. Is 11 greater than or equal to 10? Yes, it is. Or I read this as 10 is less than or equal to 11. Okay, so you're just reading it backwards. So as you're reading this way, 11 is greater than or equal to x, then you're reading it backwards. X is less than or equal to 11. Let's try another one. One is less than or equal to x minus 4. Again, we have our x on our right side. We need to get that alone. So I'm going to go ahead and I'm going to, since I'm subtracting 4, I'm going to go ahead and add 4 to both sides. These cancel out. X, and then 4 plus 1, or 1 plus 4 is 5. So now I would normally read it from left to right, but since my variable is on the right, I'm going to read it backwards. I'm going to say x is greater than or equal to 5. Say that again. X is greater than or equal to 5. Because if I read it left to right, it's 5 is less than or equal to. Now I'm going to go X is greater than or equal to. I just picked the opposite term, right? Key phrase. 5 is greater than or equal to. So I'm going to go X this way. X is less than or equal to. Okay, so I'm doing my graph now, and I have 5 is my number, so I'm going to put a circle on 5. I'm going to shade it in, and I'm reading it as X is greater than. So greater than, remember we're getting bigger, goes to the right. Those are some examples with adding and subtracting. But I also said we were going to be doing some multiplying and dividing. So I'll give you a couple examples for this. 9n is greater than or equal to 63. Well, just like solving equations, it's 9n is 9 times n. I want to get rid of the n, or get rid of the 9 to get the n to be by itself. So I'm going to divide not by both sides on 9. These 9's cancel out, and I'm left with n is greater than or equal to 7, because 63 divided by 9 is 7. So there's my solution. I need to draw my graph now. Okay, so n is greater than or equal to 7. So I'm working with 7. Greater than or equal to, since it's or equal to, I'm shading it in because it's including 7. So n is greater than. So n has to be greater than. So n could equal 8, n could equal 9, n could equal 1,000, n could equal 1,000,000. N could also equal 7. So it has to be 7 or bigger. Then that would be a true answer to our solution. Couple more examples. We have x divided by 2 is less than 4. X divided by 2 is less than 4. So when you have it this way, go ahead and put it in fraction form. X divided by 2 is less than 4. Since it's x divided by 2, inverse operation is multiplying by 2. So I'm going to multiply by 2 on both sides. Multiply by 2 on both sides. This is in fraction form, so I'm going to put it in a fraction. 2 is going to be 2 over 1. These cancel out, and I'm left with x is greater than 4 times 2, which is 8. X is less than 8, so I must graph my solution. So I just drew a line, put 5 slashes, 6, 7, 8, 9, 10, because 8 is my number that I'm working with. So I'm going to put a circle above 8. Now it's just x is greater than, it's not equal to, so I'm going to leave it open. X is less than 8, so less, we get smaller, it goes to the left. One more example I would like to give you before I let you leave for the day is if we have, again, our variable on the right side, 72 is greater than 12p. 72 is greater than 12p. Well, I have to get that p by itself. We know that 12p, we have a coefficient and variable together. 12p means 12 times p. The inverse operation for multiplying is dividing. So I'm going to divide both sides by 12. These 12 divided by 12 cancel out, and we're left with p on the left side. And then 72 divided by 12 is 6. So there's your answer, but I need to graph it. Make my 5 little slash marks in my number line. 4, 5, 6, 7, 8. And I always put my number in the middle. I'm working with 6, so I'm going to draw my circle on 6. It is 6, and it's only greater than, right? There's only the symbol. There's no equal to, so it's open. But I'm reading this from right to left, because if I read it this way, I read it as 6 is greater than P. If I read it this way, if I'm reading it left to right, it's 6 is greater than P. But if I'm reading it right to left, it's P is less than 6. So now my greater than, since I'm reading it from right to left, is now less than. So I need to now, since P is less than 6, I have to switch it that way. So let's try one more, because I want to make sure that you guys are totally comfortable with this. 20 greater than or equal to x divided by 5. 20 is less than or equal to x divided by 5. Well, I need to get my x by itself. So since I'm dividing by 5, I'm going to multiply by 5 on both sides. I need to get it by itself, so I'm going to put, and it's in a fraction form, so I'm going to put 5 over 1, and that cancels out, and I'm left with x on this side. And now I have 5 times 20. 5 times 20 is 100. So now I'm left with my solution of 100 is less than or equal to x. So I'm going to write that down. 100 is less than or equal to x. So it's less than or equal to. But since I'm reading that left to right, and my variable's on the right, I need to read it from right to left. So I'm going to say x is, and then the opposite of less than is greater than or equal to 100. So now my less than now became greater than, because I switched it, because the variables switched in on the other side. So now I'm going to draw my number line, because I have to graph it. So I have 98, 99. Okay, so now I have 100 as my number, so I'm going to draw my circle on 100, and I'm going to shade it in. But since I'm reading it from the variable to the left, x is greater than or equal to 100. So x has to be greater than, so it has to be bigger than or equal to 100. I hope this video helps. Remember to make sure that you have all your notes in your math journal. And if you need to, rewatch the video for additional support.